8 and 9. Find the zeros of the function by using the quadratic formula. Well, I don't know why in the world this is written in vertex form if I'm going to be using the quadratic formula. That's not helpful. So let's try and transform this, right? I need to multiply x minus 3 times itself and then subtract 10. So I'm going to rewrite this in standard form. If I multiply x minus 3 times itself, I'm going to get an x squared, and then a negative 3x, and a negative 3x, and then plus 9 minus 10. So if I simplify that, this function in standard form is, and I'll write it right here, I guess, f of x equals x squared minus 6 of the x's, and then a minus 1. So now I got to take this thing and I'm going to set this function equal to 0, right? So now, because I'm trying to find the roots, so here I've set my function equal to 0, and I need to use it says use the quadratic formula here, so forget about it if you wanted to complete the square. So if I'm using the quadratic formula here, a is equal to positive 1, b equals negative 6, and c equals negative 1. So if I'm plugging into the quadratic formula, right, I've got the opposite of b. b is negative 6 currently. So I've got the opposite of negative 6 plus or minus the square root of b is going to get squared, b getting squared, minus 4 times a times c. Beautiful. And I'm going to divide this entire thing by twice a. So a little simplification, right? The opposite of negative 6 is 6 plus or minus this thing inside of this square root symbol is going to look like, let's see, that's 36. Positive 36 minus a negative 4. So 36 plus 4. And then I'm going to be dividing all of that by 2. So I guess I could write it like this. It's 6 plus or minus the square root of 40 over 2. Now, that root 40 clearly has a perfect square in it because it's got 4 times 10. So I'm going to simplify that further. I'm going to take that and write it as 6 plus or minus root 40. I'll write it in 2 steps because it's the same as root 4 times the square root of 10. And I'm going to divide all of that by 2. The square root of 4 is 2, so this is 6 plus or minus 2 times the square root of 10 all over 2. So at this point, I see that I have a common factor of 2 in my numerator, and I have a factor of 2 in my denominator. So I'm going to be able to cancel that out. Just so that we're real careful, I'm going to factor out the 2 in my numerator. So that's 2 times, I'm going to divide both of those by 2. 3 plus or minus root 10. And then in my denominator, I still have this factor of 2. So now I can cancel out that common factor of 2, and we're left with the solution of 3 plus or minus the square root of 10. And those are my two roots, right? 3 plus root 10 and 3 minus root 10. Question 9 says, give the type, real or imaginary, and the number of solutions for this particular equation. Well, this is something that I use the discriminant, right, to answer. And let's quickly calculate the discriminant for this particular one. I'll call the discriminant D. And for this particular quadratic, A equals 1, B equals 14, and C equals 10. The discriminant is this B squared minus 4 times A times C. And when I plug these values in, B is 14, so I'm going to square that. And then I've got minus 4 times 1 times 10. So we're looking at 14 squared, which is large, and which I'm ashamed to say at the moment, well, thank you, calculator. It's 196, and I'm going to subtract from that 4 times 10, or 40. So my discriminant is the number 156. Well, you know what? I'm done, because the discriminant is positive, right? Whenever the discriminant is positive, the discriminant is greater than 0, I know that I have two, not toe, two, two real solutions. By the way, if the discriminant were negative, right, if d was less than 0, there would be two non-real solutions, two imaginary solutions. And if the discriminant was two non-real solutions, and if the discriminant is equal to 0, there would be one real solution. But that's just review. The answer right here is, oh, there's two real solutions for number 9.